Hello students, welcome to lecture 13 of our online chemistry classes. In the last class we were solving questions regarding empirical formula and molecular formula. I have given two questions as a homework question number 1 and 2, and I have solved these questions. You also might have solved these questions. Only thing you have to verify the answer. You have to match your answer with the answer which I have written on the board. The first question was regarding carbon percentage 54.2, hydrogen 9.1, oxygen 36.6, atomic mass of carbon 12, hydrogen 1, oxygen 16. Relative number of atoms 54.2 by 12, 9.2 by 1. 36.6 by 16, 4.516, 9.2, 2.2875, 2.788, 2.2875 is the smallest number. We have to divide all numbers by this number. 4.516 divided by 2.2875, 1.974. 9.2 divided by 2.2875, 4.02. 2.2875 divided by 2.2875 is 1. 1.974 can be rounded off to 2. 4.02 can be rounded off to 4. 1 we have to keep as it is. No need to multiply these numbers with any integer because themselves they are nearer to the whole numbers. So empirical formula will be C2H4O. 1 means no need to write that one. Empirical formula mass 2 carbon plus 4 hydrogen plus 1 oxygen 44. N equals to molecular mass by empirical formula mass 88 by 44, which is 2. So molecular formula is equal to empirical formula into that N. C2H4O multiplied by 2, that is C4H8 and O2 is the molecular formula. So very simple question. I hope that you got the correct answer. Another one was question number 2 in homework. Carbon 92.3, hydrogen 7.69. Atomic mass of carbon 12, hydrogen 1. 92.3 by 12, 7.69. 7.69 by 1, 7.69. 7.69 by 7.691, 7.69 by 7.691. C1H1. Empirical formula is CH. Empirical formula mass is 12 plus 1, 13. N equals to molecular mass by empirical formula mass. Molecular mass is given in the question, 78. This 88 also it was given in question. 78 by 36. Molecular formula is equal to empirical formula into N. CH into 6, so it is C6H6. So definitely this type of questions have been asked in every year in theory examination, and you should be very comfortable in solving these questions. For time being, we have solved these 5-6 questions. You practice these questions first, and then you can take your own initiative and you can solve many more questions when you come across to that. Now we'll go to the next part in the some basic concepts of chemistry. Quite lengthy topic, even though this year they have reduced this syllabus to 30%, and the laws of chemical combination, if you are referring textbook, there is laws of chemical combination, law of conservation of mass, law of definite proportion, like some laws were there previously that has been deleted. Dalton's atomic theory postulates, which you learn in bridge course, in which were the part of this some basic concepts of chemistry, but for this academic year that was deleted, so we are not gone through it because Anyway, there will not be questions on that. But apart from that, everything we are covering. Still 2 parts we have to cover in this: stoichiometry and stoichiometric calculations, and more concept in the solution. So these 2 concepts we have to learn, and then there's some basic concepts syllabus will complete. But today we'll start with the chemical equation. Chemical equation. The students feel chemistry difficult because they have to learn the chemical equations and they have to learn how to balance them. Some skills are required. In these 2 years, PUC first year and second year, you will come across many chemical equations and some techniques also how to balance this. But not in this, some basic concepts. Here we will define chemical equation and we will see what we mean by chemical equation, what information is given by chemical equation, and what are limitations of the chemical equations. Whenever chemical equation is before us, what conclusions we can draw on that chemical equation. So first we define chemical equation. We say that it is the symbolic representation, because we use symbols of the elements in formula of the compound. So it is symbolic representation of what? Of a chemical change. So it is the chemical change means which is permanent, which is irreversible, new substance have been formed. Chemical reaction. Chemical change is nothing but chemical reaction. And when that chemical reaction is represented symbolically, we call it as chemical equation. For example, this is CH4 gas state, simplest hydrocarbon, it is methane. When it is combusted, reacted with oxygen, we get carbon dioxide. H2 also in gas state because large amount of heat is released, so water vapors we get. This is the equation before us, but this should be balanced according to law of conservation of mass, which states that total mass of reactant is equal to total mass of product. Mass cannot be created, cannot be destroyed in a chemical reaction. There are 4 hydrogens here, only 2 hydrogens are here, so we can write this 2 here. Oxygens becomes 2 plus 2, 4, we can write here 2. I think this equation is balanced now. There is 1 carbon, 1 carbon, 4 hydrogen, 4 hydrogen, 4 oxygens, 4 oxygen, it is balanced. This part of the equation, which is to the left side, we call this as reactants. So methane and oxygen are reactants here. And this part to the right side, we call this as the products. So products are obtained from the reactants by the chemical change, and when it is represented with symbols, it is called as the chemical equation. But what are the things which this chemical equation gives us information? It gives information about various things if you are able to read it correctly. For example, this equation tells us that the one molecule of methane, why we say one? Because nothing is written here, means one. One molecule of methane reacts with 2 molecules of oxygen and it forms 1 molecule of carbon dioxide and 2 molecules of H2. This is the first type of inference we can draw from this equation. If it is balanced, if it is not balanced, if this 2 is not there, it will give us wrong information. So that's why equation should be balanced first. So it means one molecule of methane combines with two molecules of oxygen and to form one molecule of carbon dioxide and two molecules of H2. These molecules can be converted into moles, because if one molecule, if it is multiplied by Avogadro number, that becomes the moles. So we can say 1 mole of methane combines with 2 moles of oxygen and forms 1 mole of carbon dioxide and 2 moles of H2. So we can take it as molecule as well, we can take it as mole also. Regarding the mass, 1 mole of methane is nothing but 16 gram, carbon is 12, 4 hydrogen, 1, 1, 1, 1, so it is 16. This is 2 into 32. That's why it is 64 gram. This is 1 mole, carbon 12, oxygen 16 plus 16, 32 plus 12, 44 gram. And this is 2 into 16 plus 2, 18. That is equal to 36 gram. So the equation can be interpreted. One more meaning of this equation is 16 gram of methane combines with 64 gram of oxygen and forms 44 gram of the carbon dioxide and 36 gram of the H2. 64 plus 16, 74, 80, and 44 plus 36. This is also nothing but 80 grams. So law of conservation of mass is followed here. Regarding the volume ratio, if they are gases, we can talk about their volume ratio also. One volume of methane combines with 2 volumes of oxygen, forms 1 volume of carbon dioxide and 2 volumes of H2. That is also conclusion we can draw. And we can calculate this volume at STP. And we know that 16 gram is the molar mass of the methane. So it occupies 22.4 liter. This is 2 moles means 2 multiplied by 22.4, which is 44.8 liter. This is 1 mole means 22.4 liter, and this 2 multiplied by 22.4, which is 44.8 liter. It means 22.4 liter of methane combines with 44.8 liter of oxygen. Of course, if it is at STP, it forms 22.4 liters of carbon dioxide and 44.8 liters of H2. So, when equation is before us, we can interpret it in the forms of molecules, moles, mass, if they are gases, volume ratio, and their volume at the STP. Right, so this is the information given by the equation. This equation can be made more informative by writing this upward arrow. It means there is a gaseous product. Downward arrow means there is precipitate. Precipitate means insoluble solid which settles down. That's why this downward arrow. Then, if yes means it is in solid state, L means that substance is in liquid state, J means it is in gaseous state, AQ means aqueous, substance dissolved in water. This 2 arrow sign means it is reversible. When triangle is written means the particular reactant is heated. If delta H is positive, it means it is endothermic reaction. Heat is absorbed. Delta H is negative. It means it is exothermic reaction. So these are the few things which makes the equation more informative. There are two limitations of this chemical equation. One is, by equation we will not have any idea about the speed of reaction, right? Whether the reaction is fast or whether the reaction is slow, which is very important thing in chemistry, but that is not given by the chemical equation. And the equation does not give us idea about the actual amount of reactant which we have taken and the actual amount of product formed, isn't it? This 16 grams, 64 grams, 44 grams, 26 grams is theoretical condition. But when we carry out the reaction, we may not take this many grams. So how much amount of reactant is taken, and how much of product is formed, that is not given by the equation. It gives only theoretical part. In practical part, whenever we take, instead of this 16 gram, 8 gram, means we are taking half of it. But if we take 64 gram only, then how much of CO2 and H2 is formed? That will be the thing which we have to calculate numerically. So every reaction gives us different questions regarding the amounts of reactants used and amounts of product formed, which we do in calculation. But you must know what chemical equation is and what are the conclusions which can be drawn from chemical equation, how it is to be made more informative, how to read it correctly, and what are the limitations of the chemical equations. Now after learning this, we have to go to next important theoretical part. Now we are dealing with stoichiometry and stoichiometric calculations. Stoichiometry and stoichiometric calculations. So first we will define what we mean by stoichiometry. Stoichiometry. Metry means to measure, and stoichio means amount. So it is the quantitative relationship between reactants and products. Reactants and products. We'll see how that relationship is established in a particular given equation. And stoichiometric calculations. Stoichiometric calculations means the calculations based on balanced chemical equation. If we have balanced chemical equation, we can conclude about the quantitative relationship between reactant and product, and that relationship itself is called as the stoichiometry. Calculations are called as stoichiometric calculations. So I have to deal with this. This is part of our syllabus. Now, how to do this stoichiometric calculations? For that, we need balanced chemical equation. If we have balanced chemical equation, we can do stoichiometric calculations and we can learn about that quantitative relationship between reactant and product, which we call it as stoichiometry. For that, we will take one example here, because this relationship can be understood by taking different examples. So, the question number 1 is how many grams of oxygen are required to burn completely 570 gram of octane. So octane is a hydrocarbon. Octane is 8 and it is alkane. So first we are to write the balance equation. We are burning octane. C8, it is Cn, H2n plus 2. N equals to 8. So C8, H 2 into 8, 16 plus 2, 18. C8, H18 plus oxygen. We have to burn hydrocarbon. And when we burn hydrocarbon, we get carbon dioxide gas and H2O gas. This is the compulsory product form when hydrocarbon is burnt. We can go for calculation, but stoichiometric calculations are based on balanced chemical equations. So balance is required. There are 8 carbons. I will write here 8. There are 18 hydrogens. I will write here 9. Only thing is to balance is oxygen. 9 plus 8 into 2, 16. 16 plus 2, 16 plus 9, 25. If I write here 25, it becomes 25 into 2, 50. So I will make half of it. So that it becomes 12.5 into 2 is 25. We need 25 oxygens only. But as it is divided by 2, we should get rid of this 2. By this complete equation by this 2. So 1 multiplied by 2 here, we write 2 C8H18 in gaseous state. 25 by 2 multiplied by 2 to get cancelled. That's why only we have multiplied by 2. Get rid of this 2 in denominator. We get 16 CO2 plus 18 H2. Now this equation is before us. Now we can go for stoichiometric calculation. What they want to do here? They want to burn 570 gram of octane. First we'll see what the equation tells us about the mass. So this C8H18 is the octane. If we calculate the molecular mass of it, there are 8 carbon and there are 18 hydrogens. 8 into 10, 12, 18 into 1, 96 plus 18. And this 96 plus 18 is 140. So you can say that 1 mole of C8H18 has molecular mass 114 gram. So we say 2 into 114 gram of octane. Why we say 2 into 114? Because 2 we get from balanced chemical equation. and this molecular mass of C8H18 is 140 gram. How much of oxygen is required? 25 into 1 molecule of oxygen, 16 plus 16, 32 gram. Oxygen is required. So 2 into 114 gram octane. If you want to burn, we need 15 into 32 gram of oxygen. We are not burning this much of octane. How much octane is to be burned is given. 570 gram requires how much of oxygen? So you can say oxygen required is equal to, we have to cross multiply it. 570 multiplied by 25 multiplied by 32 divide by 2, again divide by 140. So if we simplify these numbers, what we get is 2000 gram. So number of oxygen required is 2000 gram. So how many grams of oxygen are required? 2000 grams of oxygen required to burn 570 gram of oxygen. How we calculate it? First we have written the equation. We balance it. We have seen how much of octane required, how much of oxygen mass wise, and then we substitute it. So every question reactant times product will be different, only numbers differs, but the way in which it is to be calculated is similar. But not all these questions are this much easy, because there is one concept called as limiting reagent or limiting reactant, and we need to calculate this using that concept. So we'll go to the next level of this particular question. Now I have defined what we mean by limiting reagent, also called as limiting reactant. Definition we can say reactant that is completely consumed. Reactant that is completely consumed. Consumed means used, disappear. When reaction goes to completion, the reactant that is completely consumed, when reaction goes to completion, is called as limiting reagent. Why this limiting reagent is important? Because moles of product, moles means amount of product, you can convert that into grams. Moles of product always determined by starting moles of limiting reactant. Moles of the product always determined by starting moles of limiting reactant. We'll understand this sentence when we use it, and for using it we'll solve one question once again. This is how the syllabus is. Concept comes numerical, concept numericals. That's why I so many numerical questions are there. You take note of this sentence already. You might have noted this. And what do you use this now? See, I will give one question. We will use this concept. 3 gram of hydrogen. 3 gram of hydrogen. 3 gram of hydrogen reacts with 2 gram of oxygen. 2 gram of oxygen to yield. Yield means to form H2. 3 questions they are asked. First one, which is limiting reactant? Which is limiting reactant? The another one is calculate maximum amount of H2O that can be formed. Of course, it depends on limiting reactant. And C, calculate the amount of one of the reactant which remains unreacted. So these are the 3 questions before us. You read these 3 questions. Three gram of hydrogen reacts with 2 grams of oxygen to form the H2O, which is limiting reactant. So we'll first write the Carnot's chemical equation, that is the most important part. Hydrogen plus oxygen. In H2O there are 2 oxygens, 2 hydrogens, 2 hydrogens, 2 oxygen, only 1 oxygen. Then 4 hydrogens, we write together. Right. Now we can write required. Required means what the balanced chemical equation suggests. It suggests that 2 mole of hydrogen reacts with 1 mole of oxygen and forms 2 mole of H2O. Right? So this is how the required number of moles are. Now we will calculate available. Available will be given in question. 3 gram. We want to convert into number of moles. Number of moles is equal to mass divided by gram molar mass. So 3 divided by 2. 2 is the molecular mass of H2. 1.5 mole. 2 grams of oxygen. 2 divided by 32. That happens to be 0.9062. Mole. Sorry, it is 29 gram. 29 gram. 29 by 32 is 0.9062 mole. Now we can say 2 moles, this is the available 0.9062 oxygen and 1.5 mole hydrogen. We can say 2 mole of hydrogen reacts with 1 mole of oxygen. From where we have written this? From the balance equation. How many moles of hydrogen we have? 1.5 moles of hydrogen reacts with how many moles of oxygen? Cross multiplication. 1.5 by 2, 0.75 mole of oxygen. So how much is required? Only 0.75 mole. And how much is present? 0.9062. So you can say moles of O2 required. And if we compare this moles of O2 available, required is 0.75 mole. Available is 0.9062. This available is given in the question and required is given by balanced chemical equation. So you can say that available is greater, isn't it? 0.9062 is greater than 0.75 mole. So you can say oxygen is excess reactant, more than needed is present, and hydrogen is limiting reactant. Right? Because for 0.9602 or 0.9062, more number of moles of hydrogen would have been required, but they are not available. So H2 is limiting reactant. We answer this first question. Calculate maximum amount of H2 that can be formed. Now leave the oxygen, because oxygen is excess. The amount of H2 formed depends on amount of hydrogen now. So you can answer this question by comparing H2 and the H2. We have to leave oxygen now, because oxygen is in excess. It will remain as the excess reactant. For example, cricket match is going on. 11 players can go for batting, but all 50 overs completed and only 5 wickets are gone. So some batsmen will be excess. Do not bat. We call it as D and B. Do not bat. So they are not contributing. So their performance will not be reflected in the scorecard. Only scorecard is for those batsmen which actually batted for that particular time. So which is excess, it will not contribute towards the formation of product. Which is limiting, which is being consumed, that only contributes to the product. So maximum amount of H2 that can be formed can be answered by this relation. So we are solving now part B. We can say 2 mole of hydrogen can form 2 mole of H2, isn't it? 2 mole, 2 mole. 1.5 mole of H2 can form, if it is 2 mole, 2 mole. If it is 1.5 mole, this is also 1.5. 1.5 mole of H2. So this is the maximum amount of H2 that can be formed. And last question we can answer. See, I have written here, but the question was calculate the amount of the reactant which remains unreacted. So we can say moles of O2 unreacted. How many moles of oxygen are unreacted? We can say it is equal to available minus required. available is 29 gram, which is nothing but 0.9062 gram mole, and required is 0.75, and that is equals to 0.1562. This much of mole of oxygen remains unreacted. So this is one question on the limiting reactant. We complete this and pause video and you can complete this. Two questions I will give you as the homework. Compulsory you have to complete that homework. Write this fast, or you can just pause the video and complete this. I will write here two questions for homework. Don't neglect this part by thinking that this is difficult. When you solve, then you realize they are not that much difficult. So question number 2, this is from textbook exercise question. In a reaction, A plus B2 gives AB2. Identify the limiting reagent, if any. Means if it is there, it is not there, it's okay. If any, in the following mixture. Some combinations are given. 300 atoms of A plus 200 molecules of B2. 100 atoms of A and 100 molecules of B2. 5 mole of A mixed with 2.5 mole of B2. And D is 2.5 mole of A plus 5 mole B2. Right. So in this A, B, C and D, you have to tell which is limiting reagent. Limiting reagent is nothing but limiting reactant. How you conclude? By this formula. One atom, one molecule. So it is very theoretical. Just by reading and looking at this equation we can conclude. For example, one atom, one molecule. 300 atoms, 300 molecules. But how many molecules are there? 200. So B2 is limiting reagent in mixture A. Similarly, you have to conclude. That's why I am giving you as homework question. I will see how you solve this. As usual, in the next class I will solve this question before you. But you take initiative. Don't bother about this limiting reagent and stoichiometry and stoichiometric calculation. These very heavy words, isn't it? We should not think that this is difficult. We should be able to solve this. If you try, you will definitely get these answers. Now, third one is nitrogen. Third one, this is homework, and this also homework, and this is from textbook exercise. At the last part, after completion combination of topics and questions are given. That is called as exercise, and you get this question here. pH2 gives 2 NH3 gas. Calculate mass of NH3 produced if 2 into 10 raised to 3 gram nitrogen reacts with 1 into 10 raised to plus 3 gram 1000 gram hydrogen. Will any of two molecules remains unreacted? Means if there is one excess and there is one limiting reagent here, that you have to identify. If yes, then only part C. If no, there is no part C. If yes, which one? And what would be its mass? So these are two questions. We solve these questions very sincerely because this concept is very important. Many MCQs have been asked on this concept. I hope that you will solve these questions once again and you will make enough practice of this. Thank you for watching this video.